So we are an initiative that is dedicated to support the Portuguese wine sector through applied research and innovation. It was a title attributed to ADVID, that is an association of wine companies that was founded in Douro region. In 2019, it was established this collaborative research. So these are our numbers. We are more than 200 associates and 70 partners. That includes wine companies, interface centers, R&D institutions, and tech suppliers. And in 2022, Advid Collab Wines and Wines joined forces with three institutions in the center of Portugal, in the region of Dão, with the Dão Regional Wine Board, the Polytechnic Institute of Viseu, and the Regional Directorate of Agriculture and Fisheries of the center. And they create this hub to align the research of Collab Wines and Wine with agenda to another region. So they are the two of the major wine regions in Portugal. So regarding the RETINA project, that we are a partner, and I will make a brief presentation. So the RETINA objective is develop advanced photonic integrated lidar and snapshot spectral images for scaling up multi-perception and precision applications. And there are two new technologies proposed: novel lidar based on peaks and quantum dots, and optical microfilters for spectral imagers. So there are three sectors for validating our projects: healthcare, automotive, and agriculture. We are part of this use case, the precision viticulture. That we are 13 partners from seven different countries. The technologies involved are for two different platforms: ground-based platform, which includes short-range lidar, hyperspectral snapshot, and quantum dot spectral snapshot, and a drone-based platform, long-range lidar, hyperspectral snapshot, and a quantum dot spectral snapshot. So I will present more our use case is the precision critical. So we have three main goals: is the detection of grapevine trunk diseases, monitoring the water stress, and the forecasts, yield estimation. So we have two validation platforms: the ground-based platform, a handheld prototype, and the drone-based one. So regarding the grapevine trunk diseases, are one of the major threats to viticulture, because they hide damage that is only visible years later. So we need to identify these plants earlier to can stop the spread. So the type of diseases are through infected material introduced in the new vineyards from nurseries, and through pruning wounds that allow the complex of fungi to colonize the plant's vascular system. So there is no cure to this complex of diseases. So we need to not only an early detection and the removal rapidly the diseases plant. So RETINA here addresses this challenge by combining combining LiDAR's structural measurements of the trunks and the canopies, and monitoring the whole plant, that trying to flag suspect finds through subtle signs that we cannot see in the field. Regarding the water stress, so the growers and us today rely on the pre-down lift water potential, but this type of measurements are very accurate, but it requires a lot of field work at night, and only provides point samples, which mean that large areas of the vineyard remain unmonitored. So we try to map through LiDAR and multispectral, hyperspectral imaging this water stress, allowing a better spatial distribution of water status of plants. And the third one is the yield estimation, harvesting forecast, that allow us to optimize our operations on the field and on the field, program or crop insurances, and a better management of the workforce. So regarding the harvesting forecast, the traditional yield estimates often rely on the counting flowers or berries or clusters by hand, so it's very labor intensive, destructive, and are prone to error. So the RETINA solution is to try a real-time estimation of harvest quantity with more accuracy. So in our use case, we have 2 experimental sites in 2 important regions, in Douro and in Dão. So our monitoring schedules covers the key road stages. In this case, the pre-flowering for the yield and the grapevine trunk diseases. So from the bunch closer to very zone to harvest, we monitor the water stress management, the yields, and the grapevine trunk diseases. And at last, the harvest, we monitor the water stress management, the yields, and the grapevine trunk diseases. So in the first phase of data collection began in 2024 season, included validating the experimental prototype, the handle health prototype, by measuring the leaf water potential, allowing work to begin on calculation of the correlations between the baseline water potential and the multispectral images obtained. So our colleagues later, they treat the images, they uploaded to one of the partners' platform, the RIA platform, for labeling and for construct our data set for our project. So thank you for your attention. So if you have any questions regarding more the viticulture use case, be free.